Okay, so we're 99% confident that our interval 0.3467 to 0.4733 will contain the true value of mu. Okay, and again, just like before, another way to think about that is if we were to construct 100 of these or do this process 100 times, where we took 100 samples of size 400 and asked students if they work full time, if we did that 100 times, we'd expect 99 of those intervals to contain the true value of mu. I'm sorry, the true value of p, not mu. The true value of p, the population percentage, who say they work full time. Okay, so moving along. Okay, the next thing we look at is finding a minimum sample size to estimate p. Okay, so if you're given a question where it says how many people must you sample, okay, in order to get these results, okay, your specific results, okay, that means you're trying to find a minimum sample size. Okay, so what you want to do is you want to solve the margin of error for n. Okay, so you go through the steps. Okay, basically you can look at this as z star over 1. Okay, then if you square both, to get rid of the square root, you can square both sides. So you need to square z star. And then when you square the square root, that'll disappear. We have to square the e on the left-hand side. Okay, so when you square that side, you take the square to both pieces there, or both factors. Okay, and then treat that as e squared over 1 cross multiply. Okay, so you would take n times e squared. Okay, we'll then take e squared to the other side by dividing by e squared, and you get n equals z squared times p hat q hat over e squared. Okay, and if you don't know p hat or q hat, then use 0.5 for both. Okay, and without going through the explanation of that, the explanation will be in the textbook. But basically that allows you the largest, it allows you the safest, to be the safest for your estimate. Because if you look at p hat and q hat being 0.5, that'll be 0.5 times 0.5, which is 0.25, compared to like 0.1 and 0.9, okay, which would be 0.09, okay, when you multiply them. Okay, so 0.5 for p hat and q hat, if you don't know what the values are, you use those to be as conservative as you can. Okay, so that is the equation that'll help you find the minimum sample size to estimate p. Okay, so looking at the examples here, how many shoppers must be surveyed to construct a 95% confidence interval to find the proportion of shoppers who spend more than 1 hour in a shopping mall? We want the margin of error to be 3 percentage points. Okay, so 95% confident. Okay, that'll have to do with your z star value. You want the margin of error to be 3 percentage points. So you want E, okay, the margin of error to be 3%. Okay, so when you substitute the values in, the 1.96, that's the middle 95% of your normal curve. 3 percentage points, that's 0.03, okay, for the margin of error. The 0.25, that's coming from 0.5 times 0.5. Because they didn't tell us they didn't tell us they took a sample, and probably someone spends more than hours like 0.3. They didn't tell us that, so we have to use this idea here, 0.5 for both p hat and q hat. Okay, so that's just all calculator work, and you get 1067.11, and you're going to always round up to the next integer on this, or the next whole number on this. You need exactly 1,067.1 people. Well, you can't take 0.1 people, so you have to go up to the next whole person, okay, which is the 1,068th person. Okay, if you read the next one, okay, I'll suggest you pause the video, and I'll just put the answer up so we can move along. Okay, so pause the video. Okay, the note I want to make on this one is that notice I used, for p hat, I used 110 over 165. Okay, so 110 out of 165. I did not round that, okay, because you're going to get a decimal that you'd have to round. Okay, so leave them as fractions if appropriate. Okay, so don't use the rounded p hat and q hat. Okay, this is 0.04 in the denominator here, 0.04, because error to be 4%. Okay, so those problems are fairly straightforward and shouldn't be too bad.